Summative I review. Question number 1 says to plot the points in the Cartesian plane. So we want to draw a Cartesian plane. You might need to plot these or select it from multiple choice. So -3 is 1, 2, 3, and then we're going to go up 2. Then we have -2 and 1, 5 and 2, and 2 and -4. So we go 2 down to -4. Example number 2, find the distance between the 2 points. So D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So we can label this as x1, y1, x2, y2. So we get x2 in this example is -6.5. x1 is -3.2. y2 is 11.5. And y1 is 8.4. So negative is positive. And then we have -6.5 plus 3.2 is -3.3 plus 11.5 minus 8.4. So we get 3.1 squared. So now we square each of those. So we have -3.3 raised to the second power. And then we have, that's going to be 10.89. And then we have 3.1 raised to the second power, which is 9.61, added to the 10.89. So we end up with the square root of 20.5. Since they want a decimal, we take the square root of 20.5, and that's approximately 4.527. It says to 2 decimals, so my answer would be 4.53 for a distance. Now to find the midpoint, the midpoint formula is x1 plus x2 divided by 2, y1 plus y2 divided by 2. So my x1 here, I'm going to call it 21, y1 is 8, x2 and y2. So we get -21 plus 12 divided by 2. And then y1 is 8 plus 13 divided by 2. So -21 plus -21 plus 12 is -9 divided by 2. And then we have 8 plus 13 is 21 divided by 2. And so that would be our midpoint. Number 4, write the standard form of the equation of the circle with the given characteristics. So they give us, let me erase this here. So they give us the center and the radius. So just the standard form of the equation is x minus h squared plus y minus k squared is equal to r squared. So this is your h and this is your k. So we're going to end up with x minus negative 3 squared plus y minus negative 6 squared is equal to 4 squared. Simplify, negative negative is positive, and negative negative is positive. 4 squared is equal to 16. So that would be our standard form. Find the center and the radius of the circle and sketch the graph. So here we can write our standard form. And we could compare what we have. So for this first one, there is no number, so that's a 0. And the second one, there's no number, so that's a 0, is equal to 25. So this is going to tell me that my center is going to be 0, 0. And then for my radius, we know that r squared is equal to 25. So we can take the square root. So r is going to be equal to 5. So that's my radius and my center. On the next one, we have x minus h squared plus y minus k squared is equal to 2r. Notice here that this is a plus sign. So we can write it as x minus negative 2 squared. Negative negative is positive, which would be this. And then here we have y minus 4 squared equals 9. And the reason I did that is so that we can have this subtraction in the middle so that we can identify our h and k. So my center is going to be negative 2 and positive 4. Now for our radius, this should be r squared. So for our radius, we have r squared is equal to 9. So we take the square root. So r is equal to 3. Now it does say to graph. So if we want to graph, let's graph the first one. We want to plot the center for it first. So that's at 0, 0. And then we use the radius to go up that many spaces. So that's right here. We go to the right 5 spaces. We go to the left. We go down. And so our circle is going to be connected by these points. And then on this side, we have our radius is negative 2 and 4. So then our radius is going to be 3. So we're going to go down 3, 1, 2, 3. And then we're going to go up 3. To the left 3. Down 3. So 1, 2, 3 would be right here. And then to the left 3. And right here. So we would draw our circle. And that would be our graph. The next one, number 6. Write the slope-intercept form of the equation of a line through the given point that is perpendicular. So first we need to find the slope of this line. So we're going to have 2x minus 3y is equal to 15. So we're going to have subtract 2x. So we get negative 3y is equal to 15 minus 2x divided by negative 3. So we get y is equal to negative 5 plus 2/3 x. So my slope here is 2/3 for this given line. Since we want a perpendicular line, then we take the reciprocal, the negative reciprocal. So we're going to use this point, this slope, and then this point. So now we can use the point slope form. We plug in our point. So 9 is our y. And then our slope is negative 3/2. And then our x is negative 4. So if we simplify, we get y minus 9 is equal to negative 3/2 x. Negative negative is positive. I'm going to add the 9 to both sides. So we get y equals negative 3/2 x plus 4 plus 9. Distribute that negative 3/2. So negative 3/2 times x is negative 3/2 x plus negative 3 times 4 is 12 divided by 2 plus 9. So if we simplify negative 12 divided by 2 is negative 6 plus 9. So finally our answer would be negative 3/2 x plus 3. And now for parallel, it's the same equation. We got the same equation. So we know that this slope is 2/3. Since it says parallel, then we use the same slope. So we're going to use 2/3 and then our point. So we plug in our information again. So we get y minus 9 is equal to our slope of 2/3 x minus negative 4. And so now we simplify. So negative negative is positive. Let's add the 9. So we get y equals 2/3 x plus 4 plus 9. So we get y equals 2/3 x plus 4 times 2 is 8/3 plus 9. So y is equal to 2/3 x plus 8/3 plus, we need a common denominator, so we're going to use 3. So in order to make that denominator a 3, I multiply by 3 over 3. 9 times 3 is 27. So we get y equals 2/3 x plus 35 divided by 3 would be our equation. And the next one, evaluate f of 3. So for these, you want to substitute 3 in for every x that you see. So we're going to have f of 3 is equal to is equal to 3 plus 13 divided by 3. 3 plus 13 is 16 divided by 3. And the absolute value of 16 is just 16 divided by 3. So f of 3 is equal to 16/3. The next one we have h of t minus h of 3. So first we can look at h of t. Well, h of t is just itself. And then h of 3, we're going to plug in a 3 everywhere that we see a t. So 3 squared is 9, times 6 is 54. Negative 3 times 3 is negative 9, plus 8. So 54 minus 9 plus 8 is minus 1. So we end up with 53. So now notice that the actual question was h of t minus h of 3. So here h of t is the original function, which we wrote here. So I'm going to write that down, 6t squared minus 3t plus 8. Then I have a minus. And then h of 3, we got 53. So my answer, we simplify, we get 3t plus 8 minus 53. So 6t squared minus 3t. And then 8 minus 53 is 45. And so h of t minus h of 3 is going to be this. Okay, the next example, we have indicate whether the equation determines y as a function of x. So here, there's two ways you can look at this. If you know what the graph is going to be, for example, letter A, we know that this is a line, y equals 4x plus 6. That's going to be a line if you graph it. It's going to be something like this. So this is going to be a line. So this will pass the vertical line test. So that makes it a function. Okay, letter B. Letter B, if we graph it, we know that since the highest power of x is a 2, that's going to be a parabola. And so that's going to pass the vertical line test. So this will also be a function. Letter C, since the x is squared and the y is squared, that means that this is going to be a circle, which means that it's going to fail the vertical line test. So that's not a function. And then y equals 5, if we were to graph that, that's going to be a line that passes through y equals 5. So this is going to pass the vertical line test. So that's also a function. Now for E, x equals 2, here's my 2, and x equals 2 is a vertical line, and that fills the vertical line test. So that's not a function. And then for letter F, we have the square root of x plus 6. So that's going to look like this. So that's also going to pass the vertical line test. So that's going to be a function. Okay, so if we go to the next one, which graph represents the function? So here you'll have a multiple choice question. If we want to figure out which graph is going to represent this, then we can graph this line. So the first part I'm going to do is f of x is equal to 1/4 x plus 2. I'm going to create a table of values. My condition is that x is less than or equal to 1. So that's going to be 1, 0, -1. You can pick more points if you like, or you can pick different points as well. And so like here, I'm going to go ahead and plug that in. So f of -1 is equal to 1/4 times -1 plus 2. So we get -1/4 plus 2. We need a common denominator, which would be 4. So that's going to be 8/4 plus -1/4. And we get 7/4. If x is 0, we get a 2. And then if x is 1, we get 1/4 times 1 plus 2. So we get 1/4 plus 2. Again, your common denominator is 4. So this is 8/4 plus 1/4 is going to be equal to 9/4. Okay, so if we plot this, let's see what it looks like. So we have 0 and 2, which is right here. Then we're going to have -1 and 7/4. 7/4, if we get an approximation, that's going to be 1.75. So we have -1 is here, and then 7/4 is going to be 1.75. So maybe like right there. And then 1 and 9/4. So 9/4, if we get an approximation, is 2.25. So that's going to be around right here. And so we can pick more points this way. So our line, now we have to notice that this has a less than or equal sign. So we're going to use a closed dot. And so if I draw this, then that would be my graph. So now we want to graph the second function. So the second function, let me write it up here. F of x is equal to negative 3x plus 6. If I do a table of values, my condition is that x is greater than 1. So numbers that are greater than 1 would be 2, 3, and so on. But I'm going to go ahead and use 1 as well, and I'll explain why in a little bit. So if we plug in 1 for x here, we get negative 3 plus 6 would be 3. If I plug in a 2, we get negative 6 plus 6 would be 0. If I plug in a 3, we get negative 3 times 3 is negative 9 plus 6 is negative 3. Now notice that my symbol is greater than, so that means when I graph, I'm going to use an open circle. So at 1, we get 3, so I'm going to use an open circle. And then we have 2 and 0, so that would be right here. And then 3 and negative 3. So about right here. Okay, so let me replot this point. Okay, so at 1, we get 3. So that would be right here. Okay, so if we graph our line, it's going to go something like this. And so that would be our graph, and then we can choose which graph is going to look like that. For the next one, we want to graph the following function. F of x is absolute value of x plus c. So f of x is equal to the absolute value of x plus c, and then they tell us what c is. So one of the things we can do here is we can plot in those values. So the first one is a negative 2. The next one is a positive 1. And then the third one is a positive 3. So if we graph this, then we get the absolute value. So remember that the parent function, which you don't have to draw it here, but I'm going to go ahead and draw it, is this here. That's the absolute value of x. But now the minus 2 tells me to move down. So I'm going to draw that in green. So my graph would be here. And then the next one is plus 1. So my graph there means to go up. So my parent function, I'm going to move it up 1. And then plus 3 means to go up 3 units. So we're going to go up 3. And it would be here. Okay, now for x squared minus c, it's the same idea. So let me go ahead and graph it. So we're going to have x squared minus negative 2, x squared minus 1, and x squared minus 3. So let's say that's a function. F of x equals f of x equals. So the first one, is x squared minus minus is positive. So that means we're going to go up 2 units. And let me go ahead and just draw our parent function. That way we can refer back to it. So our parent function is going to look like this. And this parent function, we're going to move 2 units up. And so our new graph will be here. And then the next graph is minus 1. So that means we'll move down 1. So that's going to be here. And then the next one is minus 3. So we're going to go down 3. So we would be at this point. So the next one says use the graph of f of x equals x squared to write an equation for the functions whose graph is shown. So first, we know it belongs to the x squared family. And remember that your x squared parent function is right in the center here. So in order for us to see what we have, we know that this graph is moving to the left and then it moved down. So if it moves to the left, remember that's going to be a plus. And how many units? Well, it looks like it moved over 3 units. And then it went down, it looks like 5 units. So then we say minus 5. So this would be our equation. Identify the parent function. So here, you're going to have different parent functions. So let's say, for example, you have y equals x, y equals square root of x, y equals absolute value of x, y equals x cubed, y equals x squared. And so you want to identify the parent function. Well, since you have an absolute value, that means that this would be the parent function. Y equals the absolute value of x. If you had something like this, then this is squared, so their parent function would be y equals x squared. Number 15, let g of x equals 3x minus 1 and h of x equals 5x plus 1. And they want us to find, let me go ahead and change this to h instead of the function f. So what we're going to end up with is we're going to have h of x minus g of x. So h of x is 5x plus 2 minus g of x, which is 3x minus 1. So if we simplify, we get 5x plus 2 minus 3x plus 1. So we distribute this. And we combine our like terms. So 5x minus 3x is 2x, and 2 plus 1 is 3. So that was for letter A. Now letter B, we have, oops. Letter B, we have h plus g of x, which is going to be the same as h of x plus g of x. So h of x is 5x plus 2, and g of x is 3x minus 1. So we put this together, we have 5x plus 2 plus 3x minus 1. Gather your like terms, so 5x plus 3x is 8x. 2 plus a negative 1 is going to be 1. So my h plus g of x is 8x plus 1. So let's go to number 16. Here we're multiplying, so f of g of x is the same as f of x times g of x. So f of x, let me go ahead and change it to, let me change this function to f. So here we have f of x is 5x plus 2, and g of x is 3x squared minus 1. So here we're going to multiply 5x times 3x squared is 15x cubed. 5x times negative 1 is negative 5x. 2 times 3 is 6x squared. And 2 times negative 1 is negative 2. Gather your like terms. So we get 15x cubed plus 6x squared minus 5x minus 2. So that would be our f of g. F times g of x. Now for f divided by g of x, this is f of x divided by g of x. So f of x is 5x plus 2 divided by g of x, which is 3x squared minus 1. And then there's really nothing we can do to simplify this. So my answer here is just going to be 5x plus 2 divided by 3x squared minus 1. Number 17, find g of f and f of g, and then find the domain. So let's do the first one. So g composed of f is the same as g of f of x. Okay, so in our information, f of x is x squared. And so now we're going to take x squared and plug it in for the x in g. So here's an x, so I'm going to plug in x squared minus 1. There's nothing else that I can do to simplify. So my composition g of f of x is going to be the x squared minus 1. And then the second one is f composed of g of x. So this is the same as f of g of x. So here, g of x is x minus 1. So anywhere we see an x for the function f, we're going to substitute our number. So this would be f. Okay, so anywhere we see an x, we're going to plug in x minus 1. So we're going to have x minus 1. And then that's squared. And then we need to multiply it up. So we end up with x times x is x squared minus x plus 1. So we get x squared minus 2x plus 1. So that's going to be the composition of f of g. Use the horizontal line test to determine if a function has an inverse. So here, basically, if we draw a horizontal line, if it touches in two places, then it's not an inverse. If it only touches in one place, then it's an inverse. Now, something I forgot for this over here was the domain of f of g. Okay, so first, you need to determine the domain of the inside function, which is g. So if we notice g is x minus 1, so the domain of g is just negative infinity to positive infinity. And then we find the domain of the composition. So the domain of f of g is going to be, notice here that we have x squared minus 2x plus 1. So there's no fractions, there's no square roots or logarithms. So that means that this is going to be also negative infinity to positive infinity. So your domain is to look at both of these results, and whatever they have in common, then that's what your domain would be. So the domain of f of g is going to be all real numbers in this example. 19, use algebraic test to check the following for symmetry with respect to the axis and the origin. Okay, so hopefully you saw this, that if a function is even, then there has symmetry on the y-axis. And if a function is odd, then it has symmetry on the origin. Okay, and so we also did examples where we know if a function is even, if all the exponents are even, and we know a function is odd if all the exponents are odd. And then, so that those are your cases, right? So one, if all exponents are even, then the function is even, which means that it has symmetry on the y-axis. If all exponents are odd, then the function is odd, which tells you that it's going to have symmetry on the origin. If they're a combination of both, then it's neither. We also saw that if you have a number like -3 here, if it's a constant and they're all even, so you can have number 3 here. All exponents are even and has a constant, then the function is going to be even also. Okay? But if all the exponents are odd and it has a constant, then it's going to be neither. So if we look at the first one here, let's call this A. Notice I have a 30, that's even. Then I have 12, that's even. And I have a constant. So since they're all even with the constant, then we say that this function is even. Therefore, it has symmetry on the y-axis. But if you look at the next one, this is odd, and then you have a constant. Since they're all odd, but you have a constant, then this is not even, and it's not odd. So it has no symmetry. Okay? And then the other cases were if you had something like this, if they're all even, then the function is even. Therefore, you're going to have symmetry on the y-axis. Or if they are all odd, then you have symmetry on the origin. The next one, 20, find the domain of the function. So since you have a fraction, that means there's some points that we cannot use. And so to find those points, we set the denominator equal to 0 and solve for the variable. So in this case, we get t is equal to 1. So your domain is all real numbers except 1. If we write it in interval notation, that means that it's all the negative numbers all the way to 1, and then from 1 to infinity. And that's our domain. Okay, so if you have a fraction, there's some numbers there. If you had a square root, like f of x equals square root of x plus 2, then you're also going to have restrictions. To find those, you set the radicand greater than or equal to 0, and then this is where it starts. So your domain is going to go from -2 all the way to infinity. If you don't have fractions, you don't have square roots, then your domain is all real numbers, -infinity to +infinity. Where is the function increasing, decreasing, or constant? So let's look, we'll have increasing, decreasing, and constant. So if we go from left to right, notice that the graph is decreasing. And it does that all the way until we get to this point right here. And that point is -3. Okay? So from -infinity to -3, this is decreasing. And then the graph starts to go up, right? And that happens from -3 all the way to these numbers over here. So that's going to increase from -3 to infinity. And then for constant, there's none, no interval. Okay, so this was just a quick review on Summative I. You can look at this video, but you also have that practice in WebAssign. If you have any questions, let me know.